Good morning, everyone. This is my final project in Techniques of Metallurgical Analysis, prepared by Maria Elizabeth J. Kaga, submitted to Engineer Nathaniel D. Chu. So first, we tackle about classical methods of analysis. Under this, we have copper assay, lead assay, zinc assay, and iron assay. So copper. As we all know, copper is a mineral and an element essential to our everyday lives. It is a major industrial metal because of its high ductility, malleability, thermal and electrical conductivity, and resistance to corrosion. It is also an essential nutrient in our daily diet. Uses of copper. Copper is an excellent conductor of electricity, and electrical motors, generators, and wiring are its primary use. How copper is extracted. Oxide ores are generally processed using hydrometallurgy. This process uses aqueous solutions to extract and purify copper from copper oxide ores at ordinary temperatures, usually in three steps: heap leaching, solvent extraction, and electrowinning. Copper assay is designed to measure copper with no or minimal sample treatment. The improved method utilizes a chromogen that forms a colored complex, specifically with copper ions. Copper procedures or process. The copper is dissolved and separated with sulfurated hydrogen as in the other processes, but the sulfide should be washed more completely to ensure the absence of iron salts. The following experiments show the effect of variations in the conditions of the assay. Lead. Lead is a soft, malleable, ductile, and dense metallic element. It is extracted chiefly from the mineral galena and found in ore that also contains zinc, silver, and copper. The chemical properties of lead allow this element to be used in power storage and delivery applications. Uses of lead. Lead is still widely used for car batteries, pigments, ammunition, cable sheathing, weights for lifting, weight for belts for diving, lead crystal glass, radiation protection, and in some solders. How lead is extracted. The principal method of extracting lead from galena, which is its most prominent ore, is done by pyrometallurgical method of roasting to melting the ore. Lead assay, the most commonly used reference methods for determining the blood lead concentration or electrothermal atomic absorption spectrometry and inductively coupled plasma mass spectrometry. Lead procedures or process. Lead oxide is an important component of the flux material used in the fire assay process to aid in separating target precious metals from the ore. The greatest sources of inorganic lead exposure occur from the release of airborne particulates when mixing flux material and firing cupels. Zinc. The chemical element zinc is necessary to modern life. It is the principal ore mineral in the world, the 23rd most abundant element in the Earth's crust, and fourth among all metals in the world production, after iron, aluminum, and copper. Zinc is a slightly brittle metal at room temperature and has a silver grayish appearance when oxidation is removed. Its uses range from metal products to rubber and medicines, but zinc's primary use is to galvanize steel or iron. Zinc uses. Zinc is a trace mineral, meaning that the body only needs small amounts, and yet it is necessary for almost 100 enzymes to carry out vital chemical reactions. It is a major player in the creation of DNA, growth of cells, building proteins, healing damaged tissue, and supporting a healthy immune system. How zinc is extracted. The most common underground method of ore extraction is cut and fill stoping, in which tunnels are dug to moderate depths, branching away from the mine portals. The small fraction of zinc sulfide minerals present in the ore makes beneficiation necessary in order to produce a concentrate suitable for treatment. Zinc assay provides a simple and direct procedure for measuring zinc in a variety of samples, including serum, plasma, urine, or cerebral spinal fluid. Zinc ions bind to a ligand which results in a calorimetric product proportional to the amount of zinc present. Iron. Iron is a metal and element of group 8 of the periodic table. It is a lustrous, ductile, malleable, silver gray in color. It is the 10th most abundant element in the universe. It is found in a major amount at the core of the earth in a molten form. Uses of iron. Iron is used to make alloy steels like carbon steels with additives such as nickel, chromium, vanadium, tungsten, and manganese. These are used to make bridges, electricity pylons, bicycles, trains, cutting tools, and rifle barrels. How iron is extracted. The ore is mined from large open pits by progressive extraction along steps or benches. The benches provide access to progress very deeper ore as level ore is removed. After the soil and overlying rock are cleared, the ore is drilled and blasted. Iron assay is released by the addition of an acidic buffer. Samples may be tested directly to measure Fa2 plus or reduce to measure total iron, Fa2 plus and Fa3 plus. Released iron is rich with the chromogen resulting in a colorimetric 593 nanometer product proportional to the iron present. Second, we tackle about instrumentation methods of analysis. Under this, we have spectrophotometry, X-ray diffraction, fluorescent microanalysis. What is spectrophotometry? It is a standard and expensive technique to measure light absorption or the amount of chemicals in a solution. It uses a light beam which passes through the sample, and each compound in the solution absorbs or transmits light over a certain wavelength. VIS spectrophotometer. So this is the first type of spectrophotometer, the VIS. It is an instrument used to measure absorbance and conduct quantitative analysis at the visible light 400 to 760 nanometer, known as the visible spectrophotometer. Bacterial cell density can be determined at 600 nanometer. The second type is UV-VIS spectrophotometer. It is used to measure the material of absorbance and quantitative analysis at the visible or ultraviolet light 200 to 760 nanometer. Nucleic acid and protein concentrations can be measured, and bacterial cell density can also be determined. UV spectrophotometer can be divided into single beam, split beam, double beam for different applications. Infrared spectrophotometer. It is generally infrared spectrum refers to the infrared spectrum greater than 760 nanometer, which is the most commonly used spectral region of organic compounds. Can analyze a variety of conditions, gas, liquid, solid of the sample. Fluorescence spectrophotometer, or instruments used to scan the fluorescence spectrums emitted by liquid fluorescent labels, which is widely used in scientific research, chemical industry, medicine, biochemistry, environmental protection, clinical testing, food testing, teaching experiments, and other fields. Through the through the determination of these parameters, the equipment is not only for general quantitative analysis but also can infer the molecular conformational changes in various environments, thus clarifying the relationship between molecular structure and function. Atomic absorption spectrophotometer. The method is mainly applied to detect trace components in the sample analysis. It is a powerful tool for material analysis and elemental analysis of trace metals. Applications of spectrophotometers. So first, it is useful in qualitative analysis, especially when identifying classes of compounds in both biological and pure state. The second, the spectrophotometer is essential in quantitative analysis of biochemistry, practical, such as in determining the unknown concentration of a given species through absorption spectrometry. A perfect example is the nucleic acid in a protein. Third, enzyme assay is the primary use of spectrophotometry. Fourth, identifying the molecular weight of a particular sample such as spike rate with amines, ketone compounds, aldehyde, and sugar, to name a few. So there are also other applications for spectrometers including but not limited to the following. First, identifying impurities, detecting the concentration of substances, organic compound structure elucidation, identifying the characteristic of a protein, identifying the dissolved oxygen content in a body of water, analysis of respiratory gas in hospitals, functional group detection, determining molecular weight in a particular compound, identifying classes of compounds. So, what is X-ray fluorescent? It is a non-destructive analytical technique used to determine the elemental composition of materials. It also analyzed and determined the chemistry of a sample by measuring the fluorescent or secondary X-ray emitted from a sample when it is excited by a primary X-ray source. What is X-ray diffraction? So, it is a technique for analyzing the atomic or molecular structure of materials. It is non-destructive and works most effectively with materials that are wholly or part crystalline. What are the difference between the two? X-ray diffraction and X-ray fluorescence. So, X-ray diffraction can determine the presence of amount of mineral species in sample, as well as identify phases. X-ray fluorescent will give details as to the chemical composition of a sample but will not indicate what phases are present in the sample. So, the last topic is what is microanalysis. So, microanalysis it is a chemical analysis on a sample or minute scale that usually requires spatial, very sensitive or small scale apparatus. Uses of microanalysis. It can resolve fine-scale variations in chemical elements, can be used to identify the presence and distribution of different phases in materials, requires least sample material and therefore can provide information on microscopic object. So that would be all. Thank you and God bless.